Do you ever wonder why an inequality sign flips? Let's solve this inequality and find out. I'm Mrs. C, and this is Math to Find. Let's solve negative x plus 10 is less than 4. The goal is to isolate x to find out what values of x will make this inequality true. To find out why we flip the inequality sign, we'll solve it using two different methods. First, we'll isolate x by subtracting 10 on both sides. The 10s on the left side cancel out, leaving negative x is less than. On the right side, positive 4 plus negative 10 is negative 6. We're not quite finished yet because the variable x is negative, and we need it to be positive. This is where you have two choices. You can use addition or multiplication at this point to make x positive. Let's start with using addition. We can add x to both sides. On the left side, the x's cancel out, leaving 0 is less than. On the right side, adding x to negative 6 gives us negative 6 plus x. The x is positive now, but we have this negative 6 with it. To isolate x, we will add 6 to both sides. On the right side, the 6's cancel out, leaving positive x is greater than. And on the left side, 0 plus 6 is 6. To make this inequality easier to understand, let's rewrite it so that the x is on the left side instead of the right. Both inequalities say the same thing. X is greater than 6. Okay, let's solve for x again. But this time, we'll use multiplication. We will multiply each side by negative 1 to make the x positive. On the left side, negative 1 times negative x is positive x. On the right side, negative 6 times negative 1 is positive 6. Let's compare our two solutions. Using addition, we have x is greater than 6. But using multiplication, we have x is less than 6. This doesn't make sense. How do we know which solution will make the inequality true? We can check the solutions. First, we'll use a value greater than 6, like 7, and place it back into the inequality. Negative 7 plus 10 is 3, and 3 is less than 4. It works. So to make this inequality true, the values of x must be greater than 6. But when we used multiplication, our solution was x is less than 6, which we just proved is not correct. This dilemma forced mathematicians to deal with this problem by creating a rule. When multiplying or dividing each side of an inequality by the same negative number, the inequality sign must be flipped or reversed to keep the inequality true. Remembering this rule will get you the correct solution every time, and now you know why. Let's practice. Try these two on your own. Pause the video if you need to. First up is negative 5n is less than or equal to 15. To solve for n, we will divide both sides by negative 5. On the left side, the negative 5's cancel out, leaving n. And remember, since we divided both sides by the same negative number, we need to flip the inequality sign to get n is greater than or equal to. On the right side, positive 15 divided by negative 5 is negative 3. The solution for n is any value greater than or equal to negative 3. Let's check it. Let's use an easy number to work with that is greater than negative 3, like positive 1. Substituting positive 1 back into the inequality, we have negative 5 times positive 1 is less than or equal to 15. Negative 5 times positive 1 is negative 5. Is negative 5 less than positive 15? Yes, it works. Last one. X divided by negative 3 is greater than negative 4. We can isolate x by multiplying both sides by negative 3. The negative 3's on the left cancel out, leaving x. And we can't forget to flip the inequality sign. On the right side, negative 4 times negative 3 is positive 12. The solution for x is any value less than 12. Let's check it by choosing an easy number to work with that is less than 12, like the number 9. Placing it back into the inequality, we have positive 9 divided by negative 3 is greater than negative 4. On the left side, positive 9 divided by negative 3 is negative 3. Is negative 3 greater than negative 4? Yes, you did it. You are an inequality solver. For more helpful videos, check out this playlist next. Thanks for watching, and I hope this video helped you out. And until next time, keep math awesome.